Welcome back. Today is Monday, November 30th, 2020. Here is your warm-up for today. At this time, go ahead and pause the video for a few minutes and complete the following problem. LO. Hill scholars will represent linear relationships using verbal descriptions, tables, graphs, and equations that simplify to the form y equal mx plus b. Our DOL for today, Hill scholars will complete their IXL assignment with a 90% accuracy. Graphing y equal mx plus b. The objectives: find the slope of a line given the coordinates of 2 points on a line. Graph equations that are written in the form of y equal mx plus b. And here we have a picture of Mr. Slope, Mr. Slope guy, who you will be becoming more familiar with as we cover this topic throughout the week. What is slope? Slope is the stiffness of a line. We can have a positive slope as it goes up from left to right. We can also have a negative slope as it goes down from left to right. Slope can be represented as rise over run, or also as the change in y divided by the change in x. What does the line look like when you have a positive slope? Well, again, as if you have a positive slope, it's going to be going up from left to right. If you have a negative slope, it's going to be going down from left to right. You also have some that have zero slope, which will be straight across, horizontal, without any slant or stiffness at all. And then you have no slope, which is undefined, and that's a line that's perpendicular to the y-axis and perpendicular to the x-axis and parallel to the y-axis. Definition of slope: the tilt or inclination of a line, the ratio of vertical change to horizontal change, the change in y over the change in x. And here you don't have to write this down, just watch or follow along so you can get some understanding of what we're talking about when we talk about slope. Consider the graph of y equal x minus 2, as we have it right here plotted on the plane, and compare that to the graph of y equal half of x minus 2. Notice that with the smaller slope, the line becomes flatter. Okay, now let's try increasing the slope. Now compare the graph of y equal 2x minus 2. Well, what do we notice? We notice that the larger slope, the line becomes steeper. Okay, let's look at a few more. Okay, consider the graph of y is equal x minus 2. When x is positive, the graph goes uphill from left to right. Now, if we have a negative slope, which will be y equal negative x minus 2, what do you think will happen? Which direction do you think the line will be going from left to right? That is correct. When x is negative, the graph does go downhill from left to right. Okay, let's look at the following graph. Okay, first pick 2 points on the line, and we have to pick 2 points that are at an intersection. Okay, then we find the rise and the run, and third we have to determine whether the slope is positive or negative. So on this one line, if we look at it, we can clearly see that if we go from left to right, it's going down. So what type of slope do you think it will be? Do you think it'd be a positive or a negative slope? Okay, let's locate a couple of points on this line. Remember, they got to be at an intersection. There we go. We got 2 points on an intersection. And the first thing I'm going to figure out is I'm going to try to figure out my rise, which is you got to create a right angle from one point to the other, okay? So then if I look at my rise, I've got 1, 2. So since I'm going down, that would be a -2. And the run, I've got 1, 2, 3. Is if you notice, I connected both points with a right angle, okay? Once you connect them with a right angle, then you count how many points are up and how much is your run. In this case, my rise was 2 and my run was 3. Again, we know that if we put rise over run, we will get 2/3, but we know that the slope is a negative slope, so we have to put a negative sign in front of that slope, okay? So therefore, our slope is -2/3. Let's look at a different one. Now, if we look at this one from left to right, we can clearly see that it is going upwards. So do you think that'll be a positive or a negative slope? Okay, thank you. Let's pick a couple of points on that line. Remember, those points have to be at an intersection. We don't want to get fractions or decimals. We want to get integers. Then we connect both points with a right angle and we count the rise. In this case, our rise, if we do a right angle, will be 10 and the run is 2. Therefore, we would have a fraction of 10/2, which is rise over run. And then we can also simplify that to 5, because 10 divided by 2 is 5. And it is a positive slope, okay? Again, slope-intercept form of a linear equation, y equal mx plus b, where m represents the slope and b represents the y-intercept. Any linear equation which is solved for y is in a slope-intercept form. Now again, we will be covering this throughout the week, so if you don't understand something right now, don't worry about it, because we will be covering the topic in more detail throughout the week. Okay, here we have a couple of equations that are in the form of the y-intercept form, and I want you to take a few minutes to solve for m and b on every equation. Remember that m is your slope and b is your y-intercept. At this time, go ahead and pause the video for a few minutes to allow the students to submit their answers on the chat. Graphing using slope and y-intercept form. Okay, make sure that now we're going to cover how to graph the equation on a grid. Make sure the equation is in slope-intercept form, meaning y's got to be by itself on the left side, and it's got to be equal to mx plus b. Find the slope and the y-intercept, and then you plot the y-intercept. Apply the slope rise over run to the y-intercept to get your second point, and then you draw a line connecting both points. Okay, here we have an example. First example is y is equal -1/3 x plus 2. So our starting point, which is our y-intercept point, will be 2. And our rise over run, remember rise is on top and our run is on bottom. Rise will be 1 and the run will be -3. Can repeat this again from point 1 and to find the second point, and then you draw a line through both points. Okay, so again the starting point is 2, so I put a dot on 2, and I know that my rise is 1, so I go up 1, and then my run is -3, so instead of going to the right, I'm going to go to the left 3, and that's how I find the second point. I'm going to try it one more time from that point. I'm gonna go up. Oh, sorry. Okay, so therefore, once I locate 2 points on the grid, then I could draw a line straight through it, and that would be my line. Okay, now I can move on to the next one. Okay, here's another example. Again, first we gotta identify our M, which is in this case is 3/4, and our B, which is the y-intercept, which is -2. So since the equation is already in slope-intercept form, we know that the y-intercept is -2. So we plot the point 0, -2, where the line crosses the y-axis. And here is 0, -2. The slope is 3/4, so we plot the second point of the line by moving 4 units to the right, 1, 2, 3, 4, and 3 units up, 1, 2, 3, and there's a second point at coordinates 4, 1. And then lastly, we draw a line to connect those 2 points, and that will give us our line for that equation. Okay, remember that we will be covering slope and our formula y-intercept in y-intercept form throughout the week. So don't worry if you didn't get everything that was introduced today. It's a lot of information that was given to you today, but we will be covering it in more detail throughout the week. Okay. Lastly, I need you to do your DOL once you've finished this video, and it's on IXL V1 and B5. Okay. Thank you, and have a wonderful day.